about properties of binary relations. So now we know when a relation is reflexive, irreflexive, symmetric, anti-symmetric, asymmetric, and transitive. Now we are going to see another definition, but before starting that, I want to mention something. One is that we realized when a relation is reflexive, then it cannot be asymmetric, right? Because we realized that asymmetric cannot have a pairing relation with itself, but reflexive must have any pair of one element in relation with itself. One other thing is that we realize that when something is so it cannot be like this, and when a relation is asymmetric, then we can actually realize that so nothing is in relation with itself, no element is in relation with itself, which actually means that it is irreflexive. One other thing, can we say if a relation is reflexive, so it is not irreflexive? If the relation is not empty, we can say that. So if the relation is not empty, so I have something like, for example, 1 and 1. So having this means that it cannot be irreflexive. Or if it is irreflexive and the set is not empty, it means that it is not reflexive. But it is possible that I have a relation which is not reflexive and it is not irreflexive. Like the one that we saw, for example, it is possible that I have x as 1 and 2, and I have 1, 1, but I don't have 2, 2. Because I don't have 2 and 2, it is not reflexive. Because I have 1, 1, it cannot be irreflexive. Okay, so let's see definition 3 together. Let X be a set and R is a subset of X cross X. Then, so you see, actually R is a binary relation. Then we have these 6, but actually we need you to know 3 of them. 1, R is an equivalence relation. So we call the relation R an equivalence relation if it is reflexive, symmetric, and transitive. The second one, we call R a preference relation if R is asymmetric and negatively transitive. R is partial order if it is reflexive anti-symmetric and transitive. So it is the same as this, reflexive and transitive, but it is anti-symmetric. Four, R is a strict partial order if it is asymmetric and transitive. You see, if I have asymmetric, it cannot be reflexive. So it is the reason I don't have that. Let's say I have these three, I change them in partial order by changing symmetric to anti-symmetric, and here I want to change it to asymmetric, but because asymmetric and reflexive have that conflict to each other, I only keep asymmetric and transitive. And 5, it is a quasi order if it is reflexive and transitive. And I don't have a space to write 6. Let me write it here. It is total order if it is complete partial order. Okay, now you're confused because you think that I haven't talked about complete partial order. So, okay, we don't need that. We also never talked about that negative transitive, so we don't need that preference relation. The other 4, we know about them, but actually we don't know this one as well. But it is actually pretty easy. Quasi order is reflexive and transitive, so any partial order and any equivalence relation is actually quasi order because it is already reflexive and transitive. But the ones that I want you to know are these 3, and I told you how to memorize that. Actually, it's like all of them are transitive, these 2 are reflexive, and each of them is like symmetric, anti-symmetric, asymmetric. So if I have reflexive here, it will be in conflict with this one. So it's like they are all 3 same things, but it is like symmetric, anti-symmetric, asymmetric. And because I have asymmetric, I need to remove that reflexive from a strict partial order. Okay, so the problems of that is like they give you X, they define a relation R on that, and then ask you if that relation is any of these. For example, they ask you to show it is equivalence relation. So you need to do 3 things. You need to show it is reflexive, it is symmetric, and it is transitive. In the next videos, I'm going to give some examples, and we are going to see if a relation is any of these and has any of the properties which we had in the previous video. Thank you.